Welcome back. As promised before, I would find one with an even degree multiplicity, and I did so here. So this one is x to the fourth minus 2x plus 1. Now, this does not necessarily mean that we're going to have an even degree because of the even degree polynomial, but if you think about how we factored these in the past, it's in the trinomial form. The middle term, its degree is half of the highest degree, so it would factor just like a regular quadratic would. So instead of it being x minus 1 times x minus 1, it's x squared minus 1 times x squared minus 1. And that's because of this term right here being x squared. X squared minus 1 factors into x plus 1, x minus 1. So we get x plus 1 times x minus 1 times x plus 1 times x minus 1, which if we group the like terms, we get x plus 1 quantity squared and x minus 1 quantity squared. So here we have even multiplicities. So that's going to affect our graph in just a minute. Our solutions here, or our zeros, are going to be negative 1 and positive 1. Now, again, this is an even degree polynomial. The leading coefficient is positive, so that means we're going to start high and we're going to end high. And we've also got intercepts. We got one intercept at negative 1, another intercept at positive 1, and we actually have a y-intercept here other than 0. On the last video, we had the graph crossing at the origin. That gave us the y-intercept along with one of the solutions, so we didn't bother solving for it. But in this case, we didn't cross at the origin, so we've got a different y-intercept other than the origin. 0 minus 0 is 0 plus 1 is 1. So our next intercept there, which is our y-intercept, is at 1. Now, we talked about earlier, if we had an even multiplicity, it didn't actually cross the graph, or it didn't cross the x-axis at that point, but it would touch and turn away. So we start high, we touch and turn away, we come up to 1, then we come over to the 0 of positive 1, we touch and turn away and come back up. So this is what this graph looks like. Also, if you think about the turning points, look at the degree. The degree is 4. 4 minus 1 is 3. So we have 3 at most turning points. And in this case, we do see that we turn here 1, 2, 3. So there are exactly 3 turning points here. So that's what we get as our solution. Thank you. Please work through your homework. If you have any questions, don't hesitate to send me an email. Also, your WebAssign has solutions for you as far as watching their examples or so forth. So however you need to do it to get it done, have fun with it. See you on the next video.